Okay guys, let's look here at number 6 here. And again, I've went ahead and already graphed here a parent function f of x equals the sine of x. Alright, let's look now at g of x equals 2 side of the quantity x plus pi halves. Alright, and let's identify any transformations. Well, that's a vertical stretch of 2. In other words, my amplitude, which is the absolute value of a here, is 2. And that's a vertical stretch of 2. Okay, and then how about the pi halves? Well, it's plus, so that's pi halves which way? Good, pi halves left. Okay. So all of my values are going to be shifted pi halves to the left. Okay, so really we want to begin with this pi halves left here. And let's, while we're at it, determine our period. Well, our period is 2 pi over the absolute value of b, and remember b is found in front here, and it's just a 1. Okay? So 2 pi over 1 is 2 pi. Okay, so it's going to have the same period length as my original, but it's got to shift pi halves left. Well, in a case like this where I already have the parent graph function graphed and I can see how much pi halves is, well, then I can go ahead and come back here to negative pi halves here, and I know that that's negative pi halves. Well, that would be pi halves left. All right, and at that location, I know I should be at 0, 0 because it hasn't been transformed otherwise. But of course, this would come out in my table when I got to that location. Okay, so if I'm starting here at negative pi halves, well, where do I finish? Well, let's add the period length to it. Negative pi halves plus 2 pi. And we need to convert 2 pi by multiply by 2 over 2. So negative pi halves plus 4 pi halves is 3 pi halves. So on this one, we're not going to end here at 2 pi, but we're going to end at 3 pi halves because, again, we shifted it to the left by pi halves. We did what's called a phase shift. Okay. All right, and then remember, then we take our period of 2 pi and divide it in 4 parts. 2 pi divided by 4, again, is pi halves. So I'm going to add pi halves to my starting location. Well, in this case, it's negative pi halves. So negative pi halves plus pi halves, well, that's 0. Well, so that's my next one here, it's 0. And then I'm going to add pi halves to it again. So that would be pi halves. So here's my next location, pi halves. And then I add pi halves to it again, pi, and then finally another pi halves to 3 pi halves. Okay. Okay, so what did I do? Well, I found all my transformations, and I started with that shift left, and I went ahead and put my starting point there and labeled that location as negative pi halves here. Let me get off erase, okay? And then I took my period length, I divided it in 4 parts, and I added whatever that length is to my starting location, okay? And I found all my intermediate locations. Okay, so I start at negative pi halves, and then I go through 3 pi halves instead of all the way to 2 pi, say like the last one. Okay, and of course now this is where we want to make a table. Negative pi halves, 0 pi halves. Okay, so y equals 2 sine negative pi halves goes in for x plus pi halves. Negative pi halves plus pi halves is 0. Well, what's the sine of 0? Well, 0 on, in other words, my starting point on the unit circle, that's going to be 0 for sine. Okay? So 0, that's my y value that at that location is 0, times 2 is 0. Let's do our next location. Well, 0 plus pi halves is pi halves. What's the sine of pi halves? Well, the sine of pi halves are 90. What's the y value at that location? 1. 2 times 1 equals 2. And then 0, and then at 3 pi, and then at pi, should be at negative 2. And of course, you can go in and plug all these in and evaluate them just to confirm. Okay? Okay, so let's plot those locations. Negative pi halves, I'm at 0. At 0, I'm at 2. Let's come up here and make that 2. At pi halves, I'm at 0. And then let's call that negative 2. At pi, I'm at a negative 2. And then 3 pi halves, I'm back here to 0. All right, let's go ahead and draw that in then. And ups. Okay, so let me label. G of x equals 2 sine of x plus pi halves, which is, again, that one. And notice my amplitude, it goes up as high as 2 and down as low here at as negative 2. And back to 0. And compared to the parent, it's shifted pi halves left. That's called a phase shift. And it's got a greater amplitude there. So with that pi halves left and the same period length, it's going to end here at 3 pi halves instead of, say, at 2 pi like our parent did. Okay, thank you. Okay, again, and the transformations from our parent are a vertical stretch of 2 and a shift of a horizontal translation pi halves left, right? Shifted pi halves left and a vertical stretch of 2. Okay, let's look at number 7.